Greetings and welcome, friends. Mr. Waddy here. We were talking yesterday about bisectors of triangles, which had some perhaps unexpected and interesting properties arise out of them. I don't know. Were you guys? I was pleasantly surprised when I saw these for the first time. We're on page 315, and I'm going to go over a handful of these. I've also got some a construction that we'll do that hopefully will bring some understanding to us. But here's question 4. I tried to pick some of the more interesting problems. Here we go. It says find Georgia. Here we go. It says the perpendicular bisectors of triangle ABC intersect at point G and are shown in blue. Find the indicated measures. So these orange lines are actually they did give us all 3 of the perpendicular bisectors. That's pleasant. Thank you, friends. So those are all perpendicular bisectors. Well, they told us they were, so they intersected at point G. All right, so those are perpendicular bisectors. That means this guy is congruent to this guy. That would have been 7 as well, etc. So I just want to point out they wanted us to find GA. That's it, GA. Now, you might remember that point G is called the circumcenter, right? Circumcenter, there we go. And it is equidistant from the vertices of our triangle. And so since it has that property, that means this 11 is also congruent to that, which is 11, which is congruent to that, which is 11. So GA is equal to 11. Question, side question, what is FA equal to? Yeah, that would be 9, right? Because it's a perpendicular bisector, so that would be 9. Let me see how well they drew this. If I line up my compass and line it up so that this hits one of those points. Oh, no, they didn't. Look at that. Would you look at that, friends? Look at that. Oh, wow. That's a thing of beauty. The nice thing about the circumcenter is it is the point at which you could draw a circle that passes through all 3 vertices of your triangle. All right, so that was one of the things that we had discovered yesterday. All right, so here's question 6, another slightly interesting one. What's it tell us? Here, give me some facts. Oh, these are angle bisectors of triangle XYZ. They intersect at point P. All right. Yeah, this is from the homework. Yeah. So here's the angle bisectors. Right, those are, actually those angles would not necessarily be congruent to each other. These are just congruent to the one they're adjacent to. It says find the indicated measure, find HP. Well, this point P is called the incenter, right, incenter. And it is equidistant from the sides of the triangle. Notice that distance would, of course, be measured perpendicular. And so this is 15, this is 15, this is 15. HP is equal to 15. Let's for fun, just because these are, it's just every time, it's just amazing. Look at this. Here we go. Let's scale this down. Can I draw the circle? Yeah, the circle of life. Here we go. Look at that. Think of beauty. Point P, the incenter, happens to be the center of a circle that would be inscribed within a triangle. Yeah, and isn't that lovely? It's just, there's something just wonderful about that. Pleasantly surprised. Okay, here we go. This one's going to have a little bit more work for us. Let's start by plotting some points. So H is -10, up 7, 3, 6, and one more. There's my H at right there. J is at -6, 3. So there's J, and K is at -2, up 3. There's K. Let's see, I'm going to zoom in on this just a tad so you guys can kind of better see what I'm working with. It's going to get a little more pixelated, but that's okay. So let's see. So here we are. I'm going to draw this triangle. Thing of beauty, thing of beauty. So you guys, at the very least, could have plotted points and drawn a triangle, I'd hope. Right? I mean, yeah. Oh, you have a question, or you're just like sneezing or something? Okay. All right, so there we go. Now, they wanted us to find the coordinates of the circumcenter. What that's going to require us to do, Isaiah, is find the midpoints of two of our sides, find the slopes of those sides. The slopes of perpendicular lines to those sides will, of course, be opposite reciprocals. I'll find the equations of two of those perpendicular bisectors and solve that system, which will then give me the coordinates of the circumcenter. So a lot going on there. For sake of segment JK, I think we could read that that point right there is going to be the midpoint. And let me just draw a perpendicular bisector to that. JK has a slope of 0 and the reciprocal of 0. That's a weird question, the opposite reciprocal of 0. But it's an undefined slope, and this would be the perpendicular bisector of JK. So now I could work with, I think I'll work with HJ. So let's work with HJ. This equation, by the way, does anyone know the equation of this purple line? This is x equals what number? -4. So there's one equation. Now I've got to find the equation of like this guy over here and something like that. Right, and once I find that equation, I'll solve the system of both of them. So let's do the rest of this proper. So let's find the midpoint. Midpoint formula, of course, x1 plus x2 divided by 2, y1 plus y2 divided by 2. And let's find the midpoint of HJ. All right, so HJ, I don't have a good way of, I'll just call subscript MP, HJ midpoint. H is, let's see, so that's going to be -10 plus -6 all over 2. The y coordinates for those points as well is 7 and 3, so 7 plus 3 all divided by 2. And my HJMP is going to be -16 divided by 2, which is -8. 7 plus 3 is 10 divided by 2 is 5. Let's check this out. So 1, 2, 3, 4, 5, 6, 7, 8, and up 5. 1, 2, 3, 4, 5. Yeah, so right there, that looks like it. Let me I'll plot that in purple. Lovely, lovely midpoint. So I've got the midpoint. Let's find the slope of HJ. All right, slope formula. Do you guys remember the slope formula? M. Ooh, that's like a lumpy M there. M is equal to, the slope is y2 minus y1 over x2 minus x1. Right? So there's slope formula. Let's find the slope of HJ. So that's going to equal 3 minus 7 over -6 minus -10. Right? Make sure you guys ask questions as you need to as well, because I know I was absent yesterday. -6 minus -10 is -6 plus 10, which is 4. And so the slope of HJ is going to equal -1. So that is their slope, okay, for this line, down 1 over 1, down 1 over it, down 1 over, right? You see that? If I want to find the slope of a perpendicular line to that, what is our slope going to be? Josh? Opposite reciprocals. Yeah. -1 over 1, you flip it, it's still 1, and you change the sign, it'll be +1. I like it. So our slope is 1. So here's a point and a slope of the line I'm looking for. Technically, I could just go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You could, using the graph, you could kind of figure it out from here. But let's do this algebraically, because I'm looking for that y-intercept so I can have the equation of a line in slope-intercept form. So in order to do that, I'll leave that box there. In y equals mx plus b, right, there's a lot of parts going on in this problem here. I realize that, right? I'm going to plug in m, 1 for m. I'm going to plug in -8 for x, and I'm going to plug in 5 for y. And we'll solve for b, the missing part. So 5 equals 1 times -8 plus b. So 5 is equal to negative 8 plus b. How do I solve this? Yeah. Add 8 to both sides. B is equal to 13. So the equation of our perpendicular bisector is going to be y equals 1x. You could just write that as x plus 13. Okay? So that means the y-intercept would have been at 13. But let's just draw that line, because like I said, we already had a point and we knew the slope. Right, Malik? So if I just go up 1 over 1, up 1 over 1, up 1 over 1, I could have drawn that line. Right. And we are doing this algebraically. So now what I'm going to do is I'm going to take this equation and solve that system, and that will give me the coordinates of the point that I'm looking for. So I'm trying to show it to you visually with the graph a little bit, as well as algebraically with their equations. All right, so if I want to solve the system of equations, if I have y equals x plus 13 and x equals negative 4, how do I solve that system? I'll use substitution. If x equals negative 4, I can plug this in up here, and I will have y equals negative 4 plus 13. Y equals 9. 9. And I actually already found what x was. So my point of intersection is negative 4 comma 9. That should be the answer to the overall problem. Does that make sense on my graph? Negative 4 up. You don't say. Oh, because yeah, we already knew that x equaled negative 4. All right, so I outlined kind of algebraically where this came from, and then kind of showed you graphically. If I had to do this using a compass, it is possible to construct perpendicular bisectors. I would have set my compass at one of the points, and I would want the arc to go past the midpoint, so I at least have an intersection between these. And notice if I draw this arc, keeping the same radius and moving it to this point and drawing this arc, notice that I could have constructed the perpendicular bisector, that purple line, using two intersecting arcs from both endpoints when those arcs have the same radii. Yeah? So there is a way to construct perpendicular bisectors using a compass and a straight edge as well. All right. Oh, man. Whew. Man. Yikes. All right, we got to pick up the pace. All right. N is the incenter of triangle ABC. Use the given information to find blah. All right. NF. NF is right here. Since this is the incenter, it is equidistant from all three sides. So therefore, those orange lengths are all congruent by def of Kong. Their measures are equal. ND and NE are equal in measures. So therefore, 6x minus nu, 2, is equal to 3x plus 7 by transitive property or substitution. Then let's solve algebraically. All right, I mean, like, really the geometry is like you set the things equal or adding to 180 or whatever you happen to have, and then there's just kind of some algebra from here. Right? So hopefully, I hope that's not the case, but you guys might have even just been able to, like, I don't know, those two things are equal, and then you could have solved it without the explanation of the geometry. So hopefully you're not just like setting things equal here. Let's see, but they asked us to find the indicated measure of NF. Well, NF is the same as those lengths. So let's just find NE first, or one of the other ones. So that's 3x plus 7, so plug in my 3. 3x, 3 times 3 plus 7. 9 plus 7 is 16. So all of those orange lengths, NE equals 16, therefore NF equals 16. All of those orange lengths are 16 units long. All right? So the geometry was everything up to this point. And then I guess a little bit right here and in here when I used some geometry there. But yeah, it's got some nice algebra showing up. Let's see, last question. I've got a construction. Hopefully you guys have grabbed your construction tools, right? You guys always carry them with you. I know you do. It says copy the triangle. You're welcome. I did that for you. You already had the triangle copy, right? Copy. With the given angle measures, find the incenter. The incenter is the intersection of what types of special segments? The incenter is the what?
Angle bisectors.
Angle bisectors. So let's construct some angle bisectors. So watch this. So I'm gonna pick a point. I did that. All right. I'm gonna scale this up. So I'm gonna take this a little. Whoa, dear. I'm gonna take this a little bit away from that edge, so I've got space to play. I don't know, somewhere like that, and I'm gonna draw this arc. And so that has given me 2 points along that angle's sides that are equidistant from the vertex. Now I'm going to drag my compass tool to one of those intersections, and I'm going to scale this down, and I want this to at least just barely be over the midpoint between this side and this side. Okay, so I'm going to put it right about there. Technically, you can even like make it larger than that, but I find I was able to get kind of more accurate arcs by doing that. So I'm going to do something like that. And while keeping the radius the same, I'm going to move this over here. And the intersection between these 2 arcs and the vertex will form an angle bisector. All right, so maybe some of you guys are playing along at home of the home game of geometry. This is how you would do it. So here is an angle bisector. All right, angle bisector. Let's see, let's draw one more. I'll just draw one more. This time I'll use green. Now, if it might be off a little bit, that's okay, and don't you fuss too much. So let's see. So the first arc I draw is going to be a ways out from the angle. I just need it to intersect the 2 sides of the angle. And then from those intersections, I'm going to scale my compass down so it's just over the midpoint of kind of the halfway between those 2 points. So I don't know, something like that. And draw an arc. And while keeping the radius the same, draw another arc from the other point. And let's connect those dots. See, this video is getting a little long. I'm only going to draw 2 for sake of time, although I guess it might not be as persuasive. Oh dear. You only need 2, but I think it looks cooler when all 3 are like, oh, wow, those 3 lines really are concurrent. You know, they all do really intersect at the same point. All right, so here's my point, my incenter, right, which is what we were doing. And now from there, what do I expect the incenter to be? Like, what special quality did it have? It is the center of the inscribed circle. It is equidistant from all 3 sides of our triangle. Let's see, what's a good color for this? I guess yellow is fine. Right, and look at that, thing of beauty. Yeah, let's give ourselves a round of applause. This is lovely. And I don't know, there's just something wonderfully, aesthetically pleasing about this circle that just perfectly hits all 3 sides. If I measured this point to those sides perpendicular, it would be equidistant. It's lovely, lovely, lovely. All right, thanks for watching, Internet friends. Have a great day.